Hello my dear students, this is Rima. In today's session, we will study what is Euclid's postulate. Okay, Euclid has given us some axioms and postulates. So, in what are postulates? Postulates are assumptions which are specific to geometry. Okay, so we have totally 5 postulates. The first one is a straight line may be drawn from any one point to other point. So from one point A to other point B, a straight line can be drawn, which is obvious, right? So the second postulate is a terminated line can be produced infinitely. What is a terminate line? A terminate line means a line segment. So line segment AB with points A and B. From the point A, if I produce it, it will go on infinitely, and from point B, if I produce it, it will go on infinitely. And this is the second postulate of Euclid. So postulate number 3 is a circle can be drawn with any center and any radius. So with any center A, and with any radius, we can draw a circle. With any center B and with any radius, we can draw another circle. So the postulate number 4 is all right angles are equal to one another. Right angle means what? 90 degrees. So all right angles will be equal. So this right angle and this right angle and this right angle will all be equal. This angle will be equal. Postulate number 5 of Euclid. Postulate number 5 is nothing but if a straight line falling into 2 straight lines makes the interior angle on the same side of it taken together less than 2 right angles, then these 2 straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than 2 right angles. Now we'll see what it is. Okay, first I'll draw and explain. If a straight line falling on 2 straight lines, okay, there are 2 straight lines. Say our first line, let's take this is our first line, first straight line BL. Okay, and we have another straight line also, right? If a straight line falling on 2 straight lines, right? So 2 straight lines are there. So let's see, let's take another line as M. Okay, so this is our 2 straight lines. Now it's saying if a straight line falling on 2 straight lines make an interior angle. So there are one more line that falls on these 2 lines L and M. Say this is our line N that falls on our line L and M. That is N is a straight line that falls on the straight lines M and L. Okay, and let's check how many what are interior angles. Interior angles are nothing but this angle, this angle, this angle, and this angle. See, let's number it. Okay, 1, 2, 3, 4. So this you know what is interior angles, right? We have studied that. So this is angle 1, angle 2, angle 3, angle 4. So what is the postulate? If a straight line falling on 2 straight lines makes the interior angles on the same side of it taken together less than 2 right angles. Okay, so what is the same side of this? Same side means angle 1 and 3. So angle 1 plus angle 3, and other same side is angle 2 plus angle 4. So interior angles on the same side, if it is taken together less than 2. What is 2 right angles? 2 right angles means 2 into 90, which is 180, right? So if this is less than, the sum of 1 and 3 is less than 180, then what it is saying? less than two right angles, then these two straight lines, if produced indefinitely, must meet on that side. Okay, so if we produce these, okay, these lines, it meets at a point, right? Let's say this point is P. So it meets at a point where the sum of the interior angles is less than 180. So here it is meeting. So we don't know. We'll check if 2 and 4, 2 plus 4 is less than 180. So this is true. So 1 plus 3 is less than 180 because if we extend the line, it meets at a point. And now let's extend the point, extend the line. It will meet nowhere, right? It will meet nowhere. So this is false. Okay, so what is false? Less than 180 is, this is false. So what the postulate says, if a straight line falls on two straight lines L and M, such that the interior and the sum of the interior angles on one side, that is 1 plus 3, is less than 180, then if we produce the lines, it will meet at some point P. Okay, so this is the postulate number 5. Okay, now we'll see what are Euclid's axioms. Okay, so there are 7 Euclid's axioms. The first one is things which are equal to the same thing are equal to one another. So how we'll see that things which are equal to the same thing are equal to one another? That is, imagine two things, that is to A and B. Okay, now A is equal to 5, that is things which are equal to the same thing. So same thing is 5 here, and B is equal to 5. A is equal to 5, B is equal to 5. Things which are equal to the same thing are equal to one another. So here obviously A is equal to B. So that is the first axiom of Euclid. These are actually very obvious, right? And the second axiom is, if equals are added to equals, the wholes are equal. So here, if equals are added to equals, the wholes are equal. So how we'll see that? Equals. See, take two numbers 5 and 5. Okay, equals are added to equals. So this is equals, 5 is equal to 5, right? And now 3 is equal to 3, right? So now add this. Okay, now we'll get 8 and 8. So obviously 8 will be the wholes. The wholes will be also equal. So that is, if equals are added to equals, the wholes are equal. Next axiom is, if equals are subtracted from equals, the remainders are equal. So we'll take the same number, that is 5 and 5 are equal. Okay, and 3 and 3 are equal. So this is equals and this is equals. So equals are subtracted from equals. So 5 minus 3, 2. 5 minus 3, 2. So the remainders will be equal. Fourth axiom is, things which coincide with one another are equal to one another. Things which coincide with one. So let's say I have drawn one line segment A, B. Okay, and on top of that, coinciding A and B, I'll draw one more line segment, that is P, Q. So the axiom is, things which coincide with one another are equal to one another. So line segment AB will be equal to line segment PQ, and it's obvious, right? The fifth axiom is, the whole is greater than the part. You all know that, right? So for example, consider a whole. Okay, this is a whole. Okay, and I'll take out this part. Okay, this part I'll take out. Now the whole will become only this. This part is taken out, no? So this will be always less than the whole part, right? For example, in a circle. Okay, I'm taking out this part. This is a whole. I'm taking out this part. So how the circle will be now? Okay, the circle. Okay, this is a circle, and the circle will be now. Okay, so circle will be now. So this is always greater than the part. Whole is always greater than the part. Whole is always greater than the part. So that is the fifth axiom. The sixth axiom is things which are double of the same things are equal to one another. For example, if 2x is equal to 2y, then obviously x is equal to y. The seventh axiom is things which are halves of the same thing are equal to one another. So here also, if x by 2 is equal to y by 2, then obviously s is equal to y.